A very good morning to all of you. So I cordially welcome you all for this engineering thermodynamics course. So today's classroom discussion topic is Otto cycle, and we have to find out air standard efficiency and mean effective pressure for this Otto cycle. And what is the motivation to study about the Otto cycle? That is, the motivation is it is important to know how a petrol engine works according to the Otto cycle. The outcome of the today's lecture is you should be able to calculate the air standard efficiency and mean effective pressure of Otto cycle. So here SI engine cycle, that is a spark ignition engine. So that is all the petrol engines will work according to the spark ignition principle, that is known as the Otto cycle. So here we are having the two-stroke engines as well as the four-stroke engines. So this particular diagram will give you the information about the four-stroke engines, that is the suction stroke, compression stroke, expansion or power stroke, and exhaust stroke. So how the air fuel mixture, because the air plus fuel mixture is entering into the suction stroke, which is also known as the intake stroke. And in the compression stroke, this particular air plus fuel mixture is subjected to the compressed action. That is, the piston is moving from this particular top dead center to the bottom dead center. And next is the expansion stroke or the power stroke. That is, at the end of the compression stroke, the spark is basically ignited. So here we are able to have the ignition process is taking place. So due to which the expansion of the working fluid is taking place. So due to the expansion process, we are able to get the expansion or the power stroke. Next one is the exhaust stroke, in which the piston is moving from the bottom dead center to the top dead center. So it is forcibly pushing the combustion products to escape through this particular the exhaust valve so that the cycle will be repeated. So it is the working principle of the four-stroke engine. And whenever I am saying that it is a cyclic process or is a Otto cycle. So cycle means what? That is, it is a repeated series of operations occurring in a certain order. That is, I told you that there are four different processes are taking place, like suction, compression, expansion, and expansion strokes are taking place. So that's why a cycle is defined as repeated series of operations occurring in a certain order. It may be repeated by repeating the processes in the same order. So the cycle may be of imaginary perfect engine or actual engine. So the former is called ideal cycle and the latter is called as actual cycle. So now how can we define this particular the air standard efficiency, which is also known as the ideal efficiency. So that is nothing but is a output by input only. That is the basic one. So the work done divided by the heat supplied, that is nothing but the air standard efficiency. And similarly here we are able to define the relative efficiency also. It is nothing but the ratio of actual thermal efficiency to the air standard efficiency. That is the derivation of the relative efficiency. So now how can we represent the Otto cycle on the PV diagram as well as the TS diagram? So here you can see, so what are the various processes are there on Otto cycle? So here we are able to have the two constant volume process and similarly two isentropic process. So two isentropic processes are nothing but two reversible adiabatic process. That is a constant volume heat addition process. That is the main important one whenever we are discussing about the Otto cycle. So that is the constant volume heat addition process. That is here the isentropic compression process is taking place from 1 to 2, and 2 to 3 is a constant volume heat addition is taking place whenever you are igniting the spark plug, and 3 to 4 it is a isentropic expansion of the working combustion products are taking place in the expansion stroke or the power stroke, and the 4 to 1 it is the exhaust stroke, that is the constant volume heat rejection is taking place. So whenever the question comes on Otto cycle, so to represent it on PV and TS diagram, so definitely you have to remember, so that is according to which process the heat addition and heat rejection are taking place. That is the main difference, because whether it is a compression stroke and expansion stroke, Normally, it is taking place according to the isentropic manner, but the main important difference is the heat addition is important. So here Otto cycle is also known as constant volume heat addition cycle. So here you can see, so this is the swept value. Swept value is nothing but how much amount of the working fluid is swept whenever the piston is moving from one dead center to another dead center. So that is, the piston is always reciprocating inside the engine. So whenever the piston is moving from one dead center to the another dead center, so how much amount of the volume is swept by the piston, so during its movement from one dead center to another dead center, so that is nothing but the swept value. And here it is the clearance value. So the clearance value is nothing but whenever you are having the cylindrical head, so that is here up to this particular portion only the inlet valve, that is the piston will move up to this particular top dead center only. So that is the piston will not move beyond this particular top dead center. So always there is a space in between the top head of the cylinder and here it is the top dead center. So this particular portion in which only the actual combustion process is taking place. So this particular area or the volume is known as is a clearance value. It is a clearance value. So now how can you find out the total value? So the total value Vt is nothing but is the Vs plus Vc. That is the swept value plus clearance value is equivalent to is a total value. So like this we can represent Otto cycle on the PV diagram as well as on the TS diagram. Now the next intention is how can we determine the heat standard efficiency of the Otto cycle. That is, we know that efficiency is nothing but work done by the heat supplied, and the work done is nothing but the heat supplied minus heat rejected. And we know that heat supplied and heat rejected both are taking place according to the constant volume process. So that's why here we have written CV, that is representing according to the constant volume only the heat addition and heat rejection processes are taking place. And whenever you are substituting all these particular equations, so we are able to derive the Otto cycle efficiency in terms of the compression ratio. So that is R is equivalent to V1 by V2. So it is a compression ratio. So compression ratio is nothing but is the value at the beginning of the compression stroke and divided by V2, the value at the end of the compression stroke, that is the V1 by V2. So Otto cycle efficiency is derived as 1 minus 1 by R to the power of gamma minus 1, where R is equivalent to the compression ratio and gamma is equivalent to the adiabatic index. So that is, what is the value of the compression ratio in the Otto cycle? So normally it is limited to 8, but in the modern SI engines, so the compression ratio is basically going up to is a 10 or 12 also. That is why we are restricting to only 10 or 12 compression ratio in case of the Otto cycle means. So whenever the compression ratio exceeds beyond the 10 or 12, the knocking problems we are able to experience from the Otto cycle. So that's why to avoid the knocking problems, we are restricting the compression ratio in the modern SI engines to normally 12. So that is the basic idea about the Otto cycle. So the next one is how can we find out the mean effective pressure? So the mean effective pressure is also the very important one. So here we are able to find out the mean effective pressure, that is nothing but the work done divided by the stroke volume of the swept value. That is the basic formula to find out the mean effective pressure. So by this 13.6 equation, we are able to find out the mean effective pressure. So in this particular class, it is only restricted to the working principle of petrol engine and how the Otto cycle will be represented on PV diagram and on TS diagram, and how can you find out the air standard efficiency and mean effective pressure for the Otto cycle. So let us meet on the next classroom discussion topic. Thank you one and all for listening this class about the Otto cycle. Thank you.